Alright, it's John here, and we are moving on to Clojure Koans number 13 about recursion. So let's get started here. Let's get this stuff here. Okay, so we have a couple functions we're going to define up here, and then we will evaluate them down here. And as long as it says true at the bottom when I evaluate it in the REPL, then we got it right. So let's start. Recursion ends with a base case. Okay, so we're going to call the isEven function with 0, and it should return true. So let's go up and look at that. Okay, so isEven is the function, n is the argument. If n equals 0, then we should return true. Otherwise, else we come in here and something, and then we call isEven. We call it self with n minus 1. So if we have n minus, so if 1 came in, then it would go to the else, and then it would be decremented 0, get called to return true, and then come back up. And then we would want to do the opposite of that. So we'll just, every time this gets called, we're just going to complement it. And then when it comes back out, it'll be the right answer. Okay. So we've defined that. Let's test it. And we got that one right. Okay, moving on, and starts by moving toward that base case. So if you do isEven question mark 1, then it should return false. Hey, we got it right. If we put in 17, still right. If we do 18, right, 18 is even, so true is not false, so we have it right. Good. Moving on, having too many stack frames requires explicit tail calls with recur. So what is this thing? It looks like 100,003 n. Let's put that in a REPL and see what it says. It says 100,003 n. Let's say minus that and 1. Alright, it's just a big old number, huh? 100,000. So if we did 100,000 calls, then we'd be in trouble. So we need to do this differently. So we have up here the function isEven big int. N comes in. Okay, and then we're going to use the loop recur construct, which basically lets Clojure do tail call recursion, because the Java virtual machine, it doesn't have that. So Clojure is going to help us out here. So we're going to make a loop. We'll have a variable n and a variable accumulator here, and the n variable will be initialized with that n, and the accumulator will be initialized with true. And our base case is if n is equal to 0, then we will return our accumulator, because that is already set to true initially. Otherwise, we'll recur by decrementing n and then passing in the complement of the accumulator. So that looks like it'll work. Define that, move down here to our test case, and true, we got that one right, good. Okay, so now we move on to reversing directions is easy when you have not gone far. Recursive reverse with one element. So, alright, we'll just do the first of the collection. Return it, and that should make it pass, right? First call. Parentheses there. Okay, so we have a function defined, and we will evaluate it. first of the collection. How is that false? Oops. All right. Yeah, because 1 on its own is not the same as 1 in a list. So if we stick our 1 in a vector, evaluate that. Now it's true. Great. So we solved the trivial case. A list with a single item can be reversed by returning the same list. But it gets more difficult the more steps you take. Alright, so we're doing recursion here. So let's see. We will say that if the collection is empty, then we'll return an empty vector. Otherwise, we're going to tear down our list piece by piece. So we're going to be doing recursive reverse on the rest of the collection. And then when it comes back up, we need to conj the first value. So we have the recursive reverse on the rest, and then on the way back up, we're gonna put the first of it back on there. First of the collection. Alright, let's try that out. Unable to resolve symbol. I'm missing a parenthesis here. Okay. Evaluate that, and that is a value that's defined. We're on our test case. Hey, we got it right. Just a note here. This only worked because the data structure was a vector. And so we ran this conj and we put the first onto the rest. It went to the end. Normally in a Lisp you would have you wouldn't have that vector, you'd be using a list. If we run that and then run our test case here, and it's just going to make the same thing again, 1, 2, 3, 4, 5, without reversing it, just because when you conj onto a list, it puts it on the front, and then when you conj onto a vector, it puts it on the end. So something important to remember. So if you ever get things backwards, you just switch the data structure and then you're fine, more or less. Okay, so simple things may appear simple. So factorial 1 equals 1. So if equals n and 1, then we're going to return 1. Else, everyone knows factorial, right? You just call it factorial and decrement n. Okay, factorial n. If n is equal to 1, return 1. Otherwise, you call factorial. But we need to do some multiplying, right? We're going to factorial, and we're going to do multiply n times the factorial of n minus 1. Okay. So let's define that. Good. Got that. So factorial 1 is 1, true, factorial of 2 is 2, factorial of 3 is 6, factorial 4, 24, that worked out. And for the next one, oh, Stack Overflow. Alright, because, yeah, we've got something, factorial of something huge. Doesn't work. So, we are back to our is even big int problem that the Java virtual machine doesn't do. Tail call optimization. So we need to change things up and have a loop. We need to have a value that's our accumulator, and also our initial value. Okay, so our accumulator will be 1, right? Because we're doing a multiply. If we're doing addition, we probably want to start with 0. We're doing multiply, so we want to start with 1. So our accumulator starts with 1. So if n is equal to 1, then we will return our accumulator. Else we will recur and our first variable is n, so I need to decrement n to pass in for our next loop, and then we will multiply our accumulator is going to be the product of n and the accumulator. Right, so let's see, base case 1 comes in. If n is equal to 1, we return 1, good. So, and then we're done. Otherwise, if 2 comes in, n equals 2, accumulator is 1. Then 2 is not equal to 1, we come down here, we decrement to 1, and we multiply 2 times the accumulator, we get 2. Then we move in here, n is equal to 1, and return the accumulator, which is 2. So yeah, that looks right. Let's evaluate that. What have we done? Oh, look at that. That is in the wrong place. Get rid of that. Okay, so now parentheses should be right. And we move down here. We can run some more factorials, see if they still work. True, 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 true. Still working. And now we try the big one. And it works. Great. Thanks, Clojure. You made that pretty easy on us. Alright. Thanks for watching the video.